Hi, and welcome to this next video in our series on data interpretation presentation. And in the last video we were looking at interquartile range and percentiles as measures of spread and location. But in this one we're going to take that again a little bit further, particularly with regard to this idea of spread, and look at something called variance and standard deviation. So this is just another step up. We had range as a very basic measure, then we've got interquartile range, which, let's be honest, is still not the greatest. What we're going to do now is look at the most commonly used measure of spread, which is standard deviation. And variance and standard deviation are very, very closely linked together. So here we go. Right, what we're going to do essentially is calculate, on average, how far is each data value away from the mean. That's what we're doing. And to do this, what we're going to do is work out the difference between each data point and the mean. So what I'm going to do is take my data value and calculate how far away from the mean it is, which is that expression there. We're then going to do some squaring so that values don't cancel out. So for example, if you had a value that was 5 units above the mean, and then another value that's 5 units below the mean, those two, one would be positive, one would be negative in this calculation here, so they'd cancel each other out. So what we're going to do is, to get rid of that negative element, we're going to do some squaring. Okay, don't worry about the squaring, we're going to undo that bit a little bit later on as well. So we're just going to square that, and that is just to get rid of the idea of values above and below cancelling each other out. So what we're going to do is do this for every single data value and then add them all up. So you get the sum of that squared bracket there. And so we know for an average, we add them all up and divide by how many there are. So let's do that. And so what we've got now, this thing over here, is referred to as the variance, which is, on average, how far is each value away from the mean. So our variance is the sum of the difference between each data value and the mean squared, all divided by how many pieces of data you've got. Now, I mentioned previously we've got the squaring. The standard deviation is essentially just the square root of the variance. So that square root is there just to kind of undo this squaring process. So basically all I'm going to do now is just square root the whole job lot. And so that thing there, that's our formula for the standard deviation. So these two things are very, very closely linked. The standard deviation is just the square root of the variance. And like I say, it's measuring on average how far is each data point from the mean. Right, so here we go. We've got a group of students and they're getting some test scores out of 10. So we need to work out what we're being asked to work out is the variance and the standard deviation. So what I'm going to do to begin with is set this up as a table. Now, this is logistically quite a bit of a pain, but we'll see later on, firstly, how we can do it a bit easier on the calculator, and secondly, how we can actually make this calculation a whole lot easier without having to do all of this part here. So, we've got our mean, which is, add them all up, divide by 8, so our mean is 6.25, so that means this data value here, the 5, is a distance of minus 1.25 away from the mean, and so do that for all the rest of them, and we get those values there. And now we've got to go through and square all these values. So this column here is just going to be the square of that. So minus 1.25 squared, 1.5625. So that is all of those. And again, like I say, doing all these calculations is a bit laborious, because now what we've got to do is add all of these things up. So let's add them up, which gives us that thing, the sum of the difference between the data value and the mean squared. So that's that, 43.5. And then finally for the variance, we've got to do the dividing by how many pieces of data they are. So it's that 43.5 divided by 8, which is that value there. Now, just so we know, this thing here, this is a Greek sigma. Okay. And so we say the variance is sigma squared, because this thing here on its own without the squared, that would represent the standard deviation. There you go, like I said, so that thing there, that sigma, is just the square root of the variance, which is 2.33. Now, if you're looking at that process thinking, well, that was a lot of time and effort for just to get a simple number out, you're absolutely right. It is, in this form, a real laborious calculation. Particularly, imagine if you've got a very large data set. Here we had it with 8 pieces of data and it required a full-on table like this. And also, it makes it more awkward if you've got the mean as being an awkward decimal. Here it wasn't too bad, but we still ended up with like 4 decimal places for our squarings. Imagine then if you had, like, taken out a mean that had a lot more decimals than that. And if it does, then you've also got rounding error becoming an issue as well. So all in all, this is not particularly a calculation that you ever really want to be doing. The reason I include it was just to demonstrate the process and try and get this understanding of variance and standard deviation being an average distance from the mean. Fortunately, there is a shortcut, so let's go and have a look now at how we can make life a little bit simpler for ourselves. Now, here we go. There's our formula for variance. And what I'm going to do is take that formula there and just take this bracket at the top here on top of this fraction and square it out. So that's just x minus x bar bracket times by x minus x bar. And you just multiply it out using FOIL and we get that. Now, at this point, I'm just going to jump to the result because it is a little bit long. There's other bits and pieces within here that need explaining that you don't really need to worry too much about. But it's absolutely enough just to know that when you take this thing on the top here, do a bit of manipulating, what you end up with is a very different looking formula. And this one here is a whole lot easier to use. Now, the reason this is easy to use, it breaks down to essentially two bits. We've got this bit here, which essentially is the average of the squares. So what I'm doing is taking each data point, squaring it, adding them all up, and dividing by how many I've got. So that's the average of the squares. Minus the other bit, which is essentially just the square of the average. So that's a quite nice and easy way to think about how we can calculate variance. In addition to that, we also get this formula here, which is the variance is this thing SXX over N, where that SXX is calculated using that formula there. And again, this thing here is something that's used in a lot of statistical calculations, and we're not going to go into too much detail on it. But what you do need to know is like kind of these formulas here, this one, and this one here, are all included in the formula booklet that you get given. So if you have to work with any of them, you don't have to remember them. You've got reference to them. You can look them up in the formula booklet. But I would recommend you clear on particularly this one here, this idea of average of the squares minus the square of the average. Okay, having said all that, let's just have a look at how that is going to make our lives a little bit easier. So here's our set of data again. There's the formula that we saw on the previous slide. Here comes our very simplified table. So all I've got to do now is some squaring. And then add them all up. And then just plug all the numbers into the formula. So I've got my average again. I'm going to need that here, 6.25. I've got the sum of x squared, which is that bit there. So what I've got to do now is take my formula and just plug in the bits. So there's my sum of the squares. How many bits of data? So there's my average of the squares. Take away the square of the average. Bang those numbers into a calculator, and what do you know? It pops out exactly the same result. Now, in some cases, it might be rather than the raw data you get given these values here. You can also get them off your calculator. We'll have a look at that in a second. And also the formula can be just simply just to use frequency tables. So it becomes that one there. But what I want to do now is just go back and have a look at where you can get all these values off your calculator and how you can do this calculation on the calculator. So what I'm going to do is just quickly jump out of the PowerPoint, grab the calculator and see how we do. Okay, so there's our student scores. Let me just clear off that. There we go. Right, here we go. So first thing I'm going to do is grab my stats menu. So there it is. I want single variable still. And there's my values with the frequency table turned on. So what I'm going to do now is just enter the data. Now, we haven't got a frequency table, but it doesn't matter because I can just go 5 and equals, and it automatically just puts one of those in. So that's absolutely fine. So we've got 7, 3, 8, 10, 6, 8, and 3. Okay. So there's all my data in my table. So what I'm going to do now is hit the option key. Okay, let's have a look at number 2. Okay, and there we go. We've got all the bits and pieces that we need. So let's just go through what all these things are. So we've got x bar, so that's my average. Sum of the x's, so what you get when you add them all up. Sum of the squares, if you remember there's that 356, that's what I get from adding up all of the squares of each of those values. There we go. There's the there's the variance, 5.4375. This one here, that's my variance. Okay. This one for now, we can ignore. Let's just go down and have a look at what else we've got. Likewise that one, and there's what we had before about that kind of number of values, minimum, quartiles, so on, and the maximum. And if I just go back up to that screen, that's the main screen that we're looking at. So you've got your sum of x's, your sum of x squareds. There's that one there is your standard deviation, and that one there is your variance. Okay, so let's just jump back into the PowerPoint and crack on with another example. So here we go. What we've got here is one to do with group frequencies. So there we go. And there's our formula for the mean. So we're going to need midpoints, and we're going to need midpoint times frequency, and do all the summing that we need to do. So we've got 120 pieces of data. Add all of those up. So there's our sum of the frequencies times the midpoints. And so that gives us our average, which is 27.16 recurring. Okay. Now, for the standard deviation, we're going to need sum of fx squared over sum of f. So there's our adjusted formula that we had before. So we need another column. So there's f times x squared. So all I've done here is squared the midpoint and times by the frequency. So you can see this figure here is 5 squared, which is 25, times by the 7. So I'm going to need the sum of this column now. So there it is. And so now I've got all the information I need to put into my formula. So we've got the sum of fx squared over 120, take away the mean squared, the whole thing square rooted because we're looking for standard deviation. And there we go. You've got it. And it might be a good idea for you to now kind of grab your calculators and just go back and make sure you can get all those bits and pieces off your calculator using a frequency table.